Introducing gas piping into an electrical room presents a potential hazard that must be carefully considered under the National Electrical Code, specifically Article 500 concerning hazardous classified locations. The primary concern stems from the possibility of creating a Class 1 hazardous location due to the presence of flammable gases. Class 1 locations are those where flammable gases or vapors may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Article 500.8d addresses electrical equipment and wiring in Division 1 locations. Division 1 locations are those where ignitable concentrations of flammable gases, vapors, or liquids are present continuously, intermittently, or periodically under normal operating conditions, or where ignitable concentrations may exist frequently because of repair or maintenance operations or because of leakage, or where equipment breakdown or faulty operation could release ignitable concentrations of flammable gases, vapors, or liquids, and could also cause simultaneous failure of electrical equipment in a manner that would make the electrical equipment a source of ignition. In Division 1 locations, all electrical equipment and wiring must be approved for Class 1. Group D locations and must be approved for the temperature class of the location. This means the equipment must be specifically designed and tested to prevent ignition of the specified flammable gas or vapor. The National Electrical Code further elaborates on electrical equipment and wiring in Division 2 locations in Article 500.8e. Division 2 locations are those where ignitable concentrations of flammable gases, vapors, or liquids are present only under abnormal conditions such as a container failure or system breakdown, or where volatile flammable liquids or flammable gases are handled, processed, or used but are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment, or in locations adjacent to a Class 1, Division 1 location, and to which ignitable concentrations of flammable gases, vapors, or liquids might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. Similar to Division 1 requirements, all electrical equipment and wiring in Division 2 locations must be approved for Class 1, Group D locations and must be approved for the temperature class of the location. Flexible cords used in Division 2 locations must be approved for extra hard usage, meaning they are designed to withstand the rigors of industrial environments and are resistant to physical damage and chemical exposure. The NEC mandates that equipment installed in hazardous locations be listed or certified, ensuring it meets rigorous safety standards. This listing or certification process involves thorough testing and evaluation by independent testing laboratories to confirm the equipment's ability to prevent ignition of flammable substances. EAS groups further classify hazardous locations based on the specific flammable gases or vapors present. Group D specifically includes gases such as gasoline, hexane, naphtha, benzene, butane, propane, alcohol, acetone, benzene, lacquer solvent vapors, and natural gas. Electrical equipment intended for use in Group D locations must be designed and constructed to prevent ignition of these substances. Temperature class is another critical factor in selecting electrical equipment for hazardous locations. The temperature class indicates the maximum surface temperature the equipment will reach during operation. This temperature must be below the ignition temperature of the flammable gas or vapor present. Common temperature classes include tone T2, T3, T4, T5, and 6, with tone representing the highest temperature and 6 the lowest. The selection of the appropriate temperature class ensures that the equipment will not become an ignition source. When evaluating the potential hazards of installing gas piping in an electrical room, it is essential to consider several factors. Firstly, the type of gas being transported must be identified to determine the appropriate gas group classification. Secondly, the potential for leaks or releases of gas must be assessed. If there is a reasonable likelihood of gas leaks, the entire room may need to be classified as a hazardous location. Thirdly, the electrical equipment in the room must be evaluated to determine if it is suitable for use in a hazardous location. If the equipment is not approved for Class 1, Group D locations, it must be replaced with equipment that is. In situations where gas piping is unavoidable in an electrical room, several mitigation strategies can be employed to minimize the risk of creating a hazardous location. Firstly, the gas piping can be designed with robust leak detection and prevention systems. These systems can automatically shut off the gas supply in the event of a leak. Secondly, the electrical room can be equipped with continuous gas monitoring systems. These systems can detect the presence of flammable gases and provide early warning of potential hazards. Thirdly, the electrical room can be ventilated to prevent the accumulation of flammable gases. Ventilation systems should be designed to provide adequate air exchange and to prevent the formation of explosive mixtures. In addition to the requirements for hazardous locations, outdoor equipment must also be suitable for the environmental conditions to which it will be exposed. NEMA ratings provide a standardized system for classifying the environmental protection provided by electrical enclosures. A NEMA 4 rating indicates that the enclosure is watertight and dust-tight, providing protection against rain, splashing water, and hose-directed water. In some cases, a NEMA 4X rating may be required, which provides the same level of protection as NEMA 4 but also offers corrosion resistance. The selection of the appropriate NEMA rating depends on the specific environmental conditions present at the installation location. In conclusion, introducing gas piping into an electrical room can create a hazardous location if not properly managed. Careful consideration must be given to the requirements of the National Electrical Code, particularly Article 500, as well as the environmental conditions at the installation location. By implementing appropriate mitigation strategies and selecting suitable electrical equipment, the risk of explosion or fire can be significantly reduced. It is crucial to consult with qualified electrical engineers and safety professionals to ensure that all applicable codes and standards are followed.